Okay, so this is the video notes for linear modeling. In other words, taking data and finding equations that fit that data so we can use them to predict future or past information. This is done in the real world all the time when we try to make predictions about what's going to happen in the future, or maybe some predictions as not really predictions, but maybe some looking into the past to see what happened in the past. So the way we do that back in Algebra 1, the way we did that is we plotted all the points on a scatter plot, and then we sort of just drew our hand through the data points and then calculated the equation the old-fashioned way using finding slope and then using point slope. But all that stuff is really sort of unnecessary in that you can actually do the entire thing on your graphing calculator. So today you're going to need your graphing calculator, and we're going to show you how to do linear regression using your graphing calculator. Linear regression is the way of finding the line of best fit through particular data points, and it comes up with an equation and stuff like that. So up here at the top, you'll see we have steps to go through to do this. I'm going to show you all these right now in the graphing calculator as we do an example problem. But that's the steps there, so you have those whenever you're taking your tests or quizzes. So we'll start off with these first few problems down here. So let me zoom in here. All right, so we can look at this first problem. Now, obviously, we know that this is a line, and we're given 2 points here, but we don't know the equation of the line. Again, we could do this the old-fashioned way. We could find a slope and then use one of the points in the slope to do point-slope formula and then do a little algebra and get the equation. But there's actually a much faster and less sort of more ability to get the equations right using your graphing calculator. So here are our points. So we're going to use our graphing calculator. So let me take this out here. Okay. On our graphing calculator, there is a function or a button called stat. So stat is right here. See, it's right under the delete key. So let's turn on our calculator. And what we're going to do is we're going to hit stat. Now let me sort of slide this over so we can see our points. So, and we're going to edit our stat. So we hit enter and go to edit the stat. Now you'll see I already have the points in there. For list 1, so you have your x's go into list 1. So you can see on here we have x is 0 and 10. And then our y values of 50 and 51 go into list 2. And we just click our stat button one more time. But now instead of editing, because we already have those edited, we're going to go over to calc and go down to number 4, which is linreg, or short for linear regression. We hit enter and enter one more time. Depending on what type of graphing calculator you have, you might have to hit enter a few more times. But basically, when you're done, it'll spit this out. You'll see here that the linear equation is y equals mx plus b. They use a instead of m for slope. And then all you do is fill in the information. So what this is telling us is that y equals a, or y equals 0.1x plus 50. Now you got a couple other pieces of information here, r squared and r. R squared is how closely the data is related to a quadratic, and r is how closely it's related to a line. Now, since we can clearly see the graph is a line, we're going to use the r value for 1 and that it's linear. But let's say you didn't know, like you just didn't know that if it was a line or not. You just were given a bunch of points. So you could plot them all out and see, or you can look at these numbers to tell you whether or not it is a quadratic or it is linear. Whichever one is closer to 1 wins. If you want to think of it that way, they win. The one that's closer to 1 wins, and that's the regression model you would use. But since we can clearly see that this is a line, we're going to be using linear regression. And for that matter, this unit's all about lines, so we're going to be using linear regression. But in the future, you'll have to figure out which one's which or which one's better. So there's our line. So I'm going to remove the graphing calculator now. And down here, our line is y equals 0.1x plus 50. And that's it. That's the equation of the line. So let's try this again. We'll try it using the second problem here. So again, bring out my handy dandy calculator. Try not to cut off anything there. And we're going to clear this out, go back into our stat, go to edit, and we're going to replace our numbers with the ones that are there. So 0 is an x as well as 6 is an x. And 360 goes with that x, and 0 goes with the second x. And then repeating the same process, we'll hit stat and go to calc and go down to linear regression and enter, and there it is. Now again, the r squared and the r are the same. The reason why that the r squared is negative is because the line's going down. It doesn't mean that it's worse or something like that. So our equation is y equals negative 60x plus 360. That's it. If you'd like to do the third one for practice, you are more than welcome. I'll do it right along with you here. If you want to pause the video and try it yourself and sort of pick up where we leave off here, you can check your answers. But I'm just going to do this real quick. Equation is y equals 1x, or just x, plus 75. So that's it. So now let's look over at the second page. And we could even use this for multiple points. You can use this for an infinite amount of points. Now we're not going to do this question as it's written, but I just want to show you that you can do the same thing with even larger amounts of numbers. So let's do those ones. So again, I'm going to plug these into StatPlot, go to Edit, and I'm going to place these on. The x's are 2, 3, 4, and 5. And the y's that go with those are 43, 51, 59, and 67. Go to Stat and Calc and run linear regression, and there it is. So what this is telling me, okay, is that my equation is y equals 8x plus 27. So we can make some interpretations. Basically, what this is telling us, since we're talking about parking in a parking garage and staying in there a certain amount of hours, we can assume that because this is the slope, that this represents the rate, which means that however many hours we park in there, it's going to be $8 per hour. The 27 being that this is the y-intercept. Y-intercept in real world terms means starting point. So that means that this would be where you would start. If you drove into the parking garage and grabbed a ticket and were like, oh man, this is the wrong place, I need to leave, and turned around and drove right back out 30 seconds later, you would get charged 27 bucks. That's the starting point. And then for every hour after that, you're going to pay $8 per hour. And that's the sort of interpretation of this. So last part here, we're not actually going to do, but I just want to show you. These are some scatter plots. This one's hard. If you were to put in all these points, so you would have to actually write out these points. Like this one would be a 1, 5, and this one would be 2, 2. And you would write out all these points and then plug them into the stat plot and run linear regression and see. What you would notice with this one, because the dots are all over the place, it's really hard to tell what direction the line is going, whether it's going up, down, whatever. Um, but the other lines are much closer. So what you would see in the correlation coefficient is this one would have a very poor correlation coefficient. It would have one that's closer to 0. Um, that tells you that the data is not very good, and so it's going to make its best guess of what the line is. Whereas these two here would be much better, much closer to 1. So that's it. That's linear regression. Go ahead and try the practice problems in Big Ideas.